All right, so it's Mr. Angstadt-Williams back with a stats video this time around. We're going to be talking about hypothesis testing with large samples, so we're going to focus on problems with sample sizes greater than or equal to 30. We'd like to thank our corporate sponsor, Sticky Feet Reptiles. You can find them at stickyfeetreptiles.com. So the first problem we're going to look at looks something like this, right? It says 10 years ago, the average acreage of farms in a certain geographic region was 65. The standard deviation of the population was 8. And a recent study consisting of 32 farms showed that the average was 63.2 acres per farm. They gave us a level of significance of 5% and want us to test the claim. So when we're going through a hypothesis test, there are a few things that we need to find, right? So the steps, I'm just going to walk you through the 7 steps here. The first step, you're going to need to identify your H sub 0 and H sub A, your null and alternative hypotheses. Right? So remember, the H sub 0 is your equality statements, like greater than or equal to, less than or equal to, equal to. H sub A is your inequality statements, less than, greater than, not equal to. Then we're going to identify our X bar, sigma, N, and alpha. We're going to find a z-score. We're going to place that z-score on the curve, plug it into a normal CDF to get our probability, compare that probability to our alpha value, and then make a decision. So we're using p-values here to test the hypothesis test. So in our particular example, it said that the average of the population, so our mu, was 65. So I'm going to put up here mu equals 65. Right, because it just said it was, it's just equal to, and I'm going to put a little blue C there, noting that that is my original claim. If that is my H sub 0, H sub A must be the complement, so the complement of equal to would be not equal to. So I have my mu not equal to 65 for my H sub A. And then while I'm there, I'm going to say, if I look at the H sub A, right, the tail of my graph, or my normal curve, is always based off of HA. So this would imply 2 tails. So on my curve here, I know I have something that looks like this. Okay, 2-tailed curve. It said that I had a study of 32 farms, so that's my N value. It said my standard deviation for the population was 8 acres. And it said that the average for that sample, my X bar, was 63.2. So just filling in the information they give us. And of course, our level of significance, they told us, was 5%, 0.05. So with that, I can come down here and find my z-score. For those of you that don't remember, their z-score formula I'll write down here. It's X bar minus mu over sigma over the square root of n. So I'm going to just fill the variables I have in. So 63.2 minus my mu, and my mu comes from my claim up here, which was 65, all over my standard deviation divided by the square root of n, which was 32. Right? If you're going to plug this into a calculator all at once, just be careful that you group the numerator and group the denominator together to get the right answer. So when you put that into the calculator, I always round my z-scores to 2 places. I get negative 1.27. Okay, so then I look over here on my curve. Well, if I have 2 tails and they give me the negative value, that value is going to be on the left-hand side. So I know this value over here is negative 1.27. Because it's symmetrical, I know that the right side is going to be 1.27. So in order to calculate this, I'm going to use the left side because that's the side they gave us. So I'm going to type into my normal CDF in my 84, negative 1,000, comma, negative 1.27. So that will give me the area under the curve just in this left-hand piece. Now, because I know the right-hand piece is exactly the same, because it's symmetrical, what I'm going to do is just take that value times 2 to get my actual p, right? If it was 1 tail, I wouldn't be doing that, but because it's 2 tail, I'm going to multiply it by 2. So my probability, I like to take the 4 places. So when I do the normal CDF and then multiply it by 2, the whole thing, I'm going to come out with approximately 0.2041. Once I have that p-value, I'm going to compare it back to my alpha to make a decision using the p-values. So 0.2041, how does that compare to the alpha value they gave me, 0.05? Well, of course, 0.20 is greater than 0.05. If you have greater than, your decision is going to be to fail, to reject. And remember, you always assume things off of your H sub 0. So we're going to fail to reject H sub 0. So then we go back up and we look, well, H sub 0 was our claim. So if we're failing to reject the claim, we're saying there's not enough evidence to reject their claim that the average acreage of those farms was 65. All right, so that's what we have for hypothesis testing for large samples using p-values. Your quiz will be coming shortly. Please like, subscribe, and we appreciate you watching. See you next time.